Hello students, welcome to the lecture on file handling. And after the lecture we will be able to learn the following objectives. Understand the concept of file handling. Define the file operation. Explain files with binary mode, low level. Describe the direct mapping techniques. Discuss the overflow of handling. Let's start with a brief introduction to file handling. In any programming language, it is vital to learn file handling techniques. Many applications will at some point involve accessing folders and files on the hard drive. In C, a stream is associated with a file. Special functions have been designed for handling file operations. The header file stdio.h is required for using these functions. In order to store information permanently and retrieve it, one needs to use files. Files are not only used for data. Our programs are also stored in files. The editor which one uses to enter the program and save it simply manipulates files for ones. The Unix commands cat, cp, cmp are all programs which process the files. Let's discuss the concept of file handling. Abstractly, a file is a collection of bytes stored on a secondary storage device, which is generally a disk of some kind. The collection of bytes may be interpreted, for example, as characters, words, lines, paragraphs, and pages from a textual document, fields and records belonging to a database, or pixels from a graphical image. The meaning attached to a particular file is determined entirely by the data structures and operations used by a program to process the file. It is conceivable, and sometimes happens, that a graphics file will be read and displayed by a program designed to process textual data. The result is that no meaningful output occurs, probably, and this is to be expected. Creating a file and output some data. In order to create files, one has to learn about file I/O. This is how to write data into a file and how to read data from a file. One will start this with an example of writing data to a file. One begins as before with the include statement for stdio.h, and then defines some variables for use in the example, including a rather strange looking new type. Reading R. When an R is used, the file is open for reading. A W is used to indicate a file to be used for writing. And AN indicates that one desired to append additional data to the data already in an existing file. Most C compilers have other file attributes available. Using the R indicates that the file is assumed to be a text file. Opening a file for reading requires that the file already exists. Writing, W. When a file is open for writing, it will be created if it does not already exist, and it will be reset if it does, resulting in the deletion of any data already there. Using the W indicates that the file is assumed to be a text file. Appending A. When a file is open for appending, it will be created if it does not already exist, and it will be initially empty. If it does exist, the data input point will be positioned at the end of the present data, so that any new data will be added to any data that already exists in the file. Using the A indicates that the file is assumed to be a text file. Outputting to the file. The job of actually outputting to the file is nearly identical to the outputting one has already done to the standard output device. The only real differences are the new function names and the addition of the file pointer as one of the function arguments. Closing a file. To close a file, one simply uses the function fclose with the file pointer in the parenthesis. Actually, it is not necessary to close the file because the system will close all open files before returning to DOS, but it is good programming practice for one to close all files in spite of the fact that they will be closed automatically. Now we shall talk about file operation. C supports a number of functions that have the ability to perform basic file operations, which include naming a file, opening a file, reading from a file, writing data into a file, closing a file. Closing a file. A file is closed by calling the function fclose brackets. F close brackets has the syntax as shown. fprintf brackets. This is the highest level function which writes to files. Its name is meant to signify file print formatted, and it is almost identical to its stdout counterpart, printf brackets. The syntax of the fprintf brackets statement is as given. fprintf, fp, string, variables. fscanf brackets. The analog of scanf brackets is fscanf brackets, and as with fprintf brackets, this function differs from its standard I/O counterpart, only in one extra parameter, a file pointer. The syntax of fscanf brackets statement is shown here.
So, in this lab session, we will learn about fprintf and fscanf functions. So you are quite familiar already with these two functions because the starting point of C is using printf and scanf. So these two functions provide us with access to writing on console output and reading from the user. So similarly, fprintf and fscanf, so this is the version fprintf and fscanf, so they are quite similar. So how we see, so the thing is, we want to write something into a file in which it can have somewhere, it can have integers, some floats, some character arrays, anything. So what we do is, again, it is very simple. We open a file here, then this is the fprintf. So first argument is fp, which means the where we want to write, the file pointer. So I opened a file freadwrite.txt, so that should be written, our thing should be written there. Next we see, so there are quite a few things here. First is %s, then %d, %d, and %f, which means that I'm planning to write, first will be a character array, then integer, and then a floating number. So that's what I wrote here, Saurabh 31 and 99.01. So this was written in the file, it was closed. And then now again, the thing is, if I have written, I want in the future to retrieve it. So what are the things I have to retrieve? One is the name, 2 integer numbers, and 1 floating point number. So what happens, again, I have to open the file. So fp is equal to fopen, and I open that same file in read mode. And now what I do, because now I'm reading from somewhere, so in scanf it was input from the user, but here it's input from the file. So I pass the file pointer, what control string I have to use, what are the things I'm going to read. So first thing is %s, %d, %d, %f, which means I want in the file, I'm assuming here. So if I'm reading like this, so it means in the file, the first, in each line, the first element will be a string, then 2 integer numbers and 1 floating point number. So this way I read it, and then I close, and then just for check I should print if it is working fine. So let's see, so lastly I printed the string, and let's see if it works. So I run the command, I run this code, and let's see, so it is freadwrite command. So let's see if freadwrite.txt is formed, and it is formed, and there is written Saurabh, which is %s, then 30, then 1, and 99.01002. So this was written here, and then we read. So this explains the code for fprintf and fscanf. So this ends our lecture. To summarize, in this lecture, in the lab session, we learnt about fprintf and fscanf functions. So we first provide the file pointer to this one, then we have whatever the %s, %d, whatever you want to write, and then the variables you define. Similar is for fscanf. This is very easy and one of the best functions to write something in your files and read from it. But the only thing you have to remember is whatever way you write, you have to read in the same way.
Let us now talk about creation. A file is opened by a call to the library function, fopen brackets. This is available automatically when the library file stdio.h is included. There are two stages to opening a file. Firstly, a file portal must be found so that a program can access information from a file at all. Secondly, the file must be physically located on a disk or as a device or whatever. The fopen brackets function performs both of these services, and if in fact the file it attempts to open does not exist, that file is created anew. The syntax of fopen function is as shown. The operation mode is also a string chosen from one of the following: R, open file for reading; W, open file for writing; A, open file for appending; RW, open file for reading and writing. Copy. This program copies a file. Firstly, one will specify the file to copy, and then one will enter the name of target file. It is also necessary to mention the extension of file also. Delete. This C program deletes a file which is entered by the user. The file to be deleted should be present in the directory in which the executable file of this program is present. Extension of the file should also be entered. Remove macro is used to delete the file. Update. It is important to check that the number of blocks expected is the same as the number received, because something could have gone wrong with the reading process. Text files. A text file can be a stream of characters that a computer can process sequentially. It is not only processed sequentially, but only in forward direction. For this reason, a text file is usually open for only one kind of operation: reading, writing, or appending at any given time. Binary files. Depending upon the way file is open for processing, a file is classified into text file and binary file. If a large amount of numerical data is to be stored, text mode will be insufficient. In such case, binary file is used. Working of binary files is similar to text files with few differences in opening modes, reading from file and writing to file. Now let's talk about files with binary mode. Normally, a programmer can get away with using the high-level input-output functions, but there may be times when C's predilection for handling all high-level input-output as text files becomes a nuisance. These are open brackets, close brackets, create brackets, read brackets, write brackets, rename brackets, unlink brackets, remove brackets, lseek brackets. File descriptors. At the low level, files are not handled using file pointers, but the integers known as file handles or file descriptors. A file handle is essentially the number of a particular file portal in an array. In other words, for all the different terminology, they describe the same thing. Now let's talk about the direct mapping techniques. The three direct mapping techniques are direct, full associative, set associative. Each of these depends on two facts. RAM is divided into blocks of memory locations. In other words, memory locations are grouped into blocks of 2n locations, where n represents the number of bits used to identify a word within a block. These n bits are found at the least significant end of the physical address. The cache is organized into lines, each of which contains enough space to store exactly one block of data, and a tag uniquely identifying where that block came from in memory. Direct mapping. Remember that direct mapping assigned each memory block to a specific line in the cache. If a line is already taken up by a memory block when a new block needs to be loaded, the old block is trashed. Full associative mapping. In full associative, any block can go into any line of the cache. This means that the word ID bits are used to identify which word in the block is needed, but the tag becomes all of the remaining bits. Set associative mapping. This is the one that one really needs to pay attention to, because this is the one for the homework. Set associative addresses the problem of possible thrashing in the direct mapping method. Now let's discuss overflow of handling. There are two basic categories of overflow: stack overflows and heap overflows. Stack overflows. In most operating systems, each application has a stack, and multi-threaded applications have one stack per thread. This stack contains storage for locally scoped data. The stack is divided up into units called stack frames. Each stack frame contains all data specific to a particular call to a particular function. Heap overflows. The heap is used for all dynamically allocated memory in the application. When one uses malloc, the C operator or equivalent functions, to allocate a block of memory or instantiate an object, the memory that backs those pointers is allocated on the heap. Now in the end, let us summarize what we have learned in this lecture. When a file is opened for writing, it will be created if it does not already exist, and it will be reset if it does, resulting in the deletion of any data already there. Real-life situations involve large volume of data, and in such cases, the console-oriented I/O operations pose two major problems. It becomes cumbersome and time-consuming to handle large volumes of data through terminals. A file is opened by a call to the library function, fopen brackets. This is available automatically when the library file stdio.h is included. A text file can be a stream of characters that a computer can process sequentially. It is not only processed sequentially, but only in forward direction. Binary files can be either processed sequentially or, depending on the needs of the application, they can be processed using random access techniques.